Hey Valley Middle, welcome back to another math video. Tonight we're going to explore the world of relative frequency, but let's first start off with a baseball trivia question. Who is this guy? One of the greatest baseball players of all time, in my opinion. I grew up watching him, love to see him play. You should know who he is, and if you don't, you will by the end of the night. All right, let me get back to my target page here. Officially, our target is 9.RF. No number tonight because it's not in the book. I can compare relative frequencies with known probabilities. Let's do this thing. Here's a sample travel survey. They asked 92 people how they got to work, and here are the results. 35 took a car, 42 took public transport, 8 rode a bicycle, and 7 walked. Here's the question in red. What are the relative frequencies for these various methods of getting to work? Well, to calculate the relative frequency, you just make a fraction. You take the 35 people who did it out of a total of 92. 35 over 92. Pop it into a calculator, you're going to get 0.38. Public transport, it was 42. There they are, right there, 42 out of a total of 92. Pop in the calculator, you got 0.46. These answers are all rounded to the second decimal place. So when you add all these up, you're going to get 1.01. Typically, you would only get 100% or 1.0. Can you guess why? You're right. Because of the rounding, sometimes it'll come out to be a little bit more. But if you add up 35, 42, 8, and 7, you'll get exactly 92. All right. Tonight, our definition, relative frequency, how often something happens, divided by all outcomes. Our first example, if your team won 9 games from a total of 12 games, the frequency of winning is 9. That's how many games you won. The relative frequency is 9/12, 9 out of a possible 12 games. Divide that out, you'd have 75%. Here's another quick example. 300 cars coming off assembly line. 12 of them have brake problems. Let's set this problem up. Here's 12 with brake problems out of 300. What is the frequency? Calculate the relative frequency of one having brake problems. Give the answer as a percentage. So if I divide 12 divided by 300, I get 0.04. Or if I move it 2 spots, 1, 2, the decimal, I would have 4%. On the other hand, 288 out of 300 didn't have brake problems, right? Or 96% of them. A lot of times they'll ask for the relative frequency of both. Here's like the event and then the opposite of the complementary event. All right, let's try some problems. First problem. We cover this one up so you can just focus on one. 25,000 new car buyers found that 750 of them had major mechanical problems in the first year of operation. Calculate the relative frequency of, question A, having a mechanical problem the first year. So 750 out of 25,000. Set it up as a fraction and then just divide them out. 750 divided by 25,000, 2, 3. I get 0.03. There's my relative frequency. Or if I want to express it as a percent, 1, move that decimal 2 spots to the right, I get 3%. All right? Multiplying by 100. Problem B. What is the relative frequency of not having a mechanical problems? Well, it'll be the opposite. So there would be 24,250 cars that didn't have a problem. So that would be 0.97 or 97%. All right, next problem. Sometimes they show you a bar graph, a circle graph, a line graph, and they ask you to do some manipulation. So I think the hardest is the circle graph. Okay, Anna did a survey where she asked all the children in her school to name their favorite pet. And they put the results onto a pie graph, a 360-degree pie chart. So what we want to know is what the relative frequency for a rabbit is. Well, if you add all these up together, you'd have 360. So I put 360. And if you look at rabbit, it's 25. So I've got 25 over 360, which really means 25 divided by 360. If I do that, I get 0.833. That didn't come out right. Let me try that one. 25 divided by 360. I get 0.069. All right. Now, if I take a look at that, I want it rounded to the nearest hundredth. So I have to look at the thousandths And that is a 9, which is big enough to bounce that number up to a 0.07. We round up to 0.07, which of course is 7%. Relative frequency for rabbit being the favorite pet, 7% or 0.07. All right, here's a problem for you to try. Roger's a tennis player. He won 175 of his last 200 matches. Here's your first one. What is the relative frequency of Roger? Let's just go with Roger winning. Go ahead and see if you can calculate that. All right, let's see how you did. Well, you probably did 165 divided by 200. And if you put that into a calculator, you would have had 0.825 multiplied by 100 here to get to the percent. It would be 82.5%. Good job. All right, let's try B, and we'll just do the winning again. After Roger has some time off from tennis, he comes back and wins only 6 of 20 matches. For this period of time, what is the relative frequency? Go ahead and see if you can calculate it out. All right, let's take a look and see how you did. Well, it was 6 wins out of 20. If I pop that into the calculator, I'm only going to get 0.3. Move that 2 spots, 1, 2. I have to add my placeholder. I got 30%. He went from 82% to 30%. Roger, you need to keep playing. Don't take time off. You could have also calculated his losing percentage too, and it'd just be the opposite of the winning. All right? If he's winning 30% of the time, that means he's losing 70% of the time. Okay? All right. You know there's going to be a yeah, but. So here it is. Yeah, but. Take a look at this problem. Jane did a count of the number of times each of the vowels occurred on one page of her book. And here are the following results. So here's the frequencies. Here are the times at the A, 126 A's. E appeared 201 times. I appeared 107 times. O appeared 120, and U appeared 46. So you're going to get questions about charts like this. They're going to say, what was the relative frequency of the vowel A? Well, the only way you can figure that out is if you add all of these numbers up. Because you have to know out of how many vowels were there 126 A's. So I'm going to help you with that. The total is 600. So we want to know what was the relative frequency of the vowel A. So let me get A out here, get my calculator, clear that at this time. I keep forgetting to do that. So I had 126 A's, 126, starting to sound like the Khan Academy guy, divided by a total of 600. Equals 0.21. So here's my answer, 0.21. I'm just going to grab that over here and I'll put that in my chart. So now we've got the relative frequency for the A. Now you might wonder what these other numbers are. Well, sometimes they give you the other relative frequencies. So I actually calculated a few out. I calculated out the E, and I calculated out the O, and I calculated out the U. Now here's another type of question you'll sometimes be asked. What is the difference in relative frequency between the vowels E and I? Well, E, the relative frequency is 0.34 or 34%. The I we don't know, so we got to calculate the I first. So let's get my calculator here. So we had 107 I's, so let me clear it one more time. 107. I need to divide that by a total of 600 again, just like a fraction. I get a total of 0.178. Well, I'm going to round that to the closest hundredth, so 0.178. That would be 0.18, so I'm going to get that guy. So now I've got this figured out. I got my chart complete. All right, I got all the relative frequencies here. So let me look at my question again. What is the difference in relative frequency between the vowels E and I? So difference means subtract. So E, let me get my E. My E is 0.34, so I'm going to move this right here. 0.34 minus the I. The I is 0.18. If I were to pop that into a calculator or do that out by hand, I would find that the difference in relative frequency is 0.16. So sometimes they're going to ask you to manipulate the data on those charts. You just have to read the questions carefully. You can do this. You can do this. All right, you're ready for the ticket to the show. Here it is. One question. At the opening of ski season, there has been sufficient snow for skiing 37 out of the past 50 years. Calculate the relative frequency of sufficient snow at the beginning of the ski season. Please express it as a decimal and as a percent. All right? All right, you ready for the answer to the trivia question? I bet you many of you know who that is. If not, I bet you could ask a parent. This is Hank Aaron, Hammer and Hank, childhood hero. 755 home runs. He is the true home run king. I don't think Barry Bonds is because he used steroids. He appeared in 21 All-Star games. Most MLB players today, they feel successful if they appear in one All-Star game. They feel like a rock star if they appear in 2 or 3. This dude was in 21.